In this video, I will show you how you can work with ideal gases when the ideal gas goes from one state. Let's say that this is state 1, when the ideal gas goes from one state to another state. So let's say here, let's call this state 2. So in my previous video, I showed you how you can do the calculations if your ideal gas is in a specific state. Now, what I have is an ideal gas atoms that undergo a process. In this case, what I will choose, I will say that the volume of state 2, of the gas in state 2, is 2 times the volume of the gas in state 1. So I'm doubling the volume of the ideal gas system, and I keep the temperature the same. Now let's go. I'm gonna show you how you can do this work on a new board. So for state 1, what I will do, I know that my ideal gas obeys the ideal gas law, and I will write the same thing for state 2, because in state 2 I continue to have the same ideal gas. I haven't changed anything. I have changed the volume and the pressure, but it's the same system. Now, as I mentioned in this example, I will say that the temperature between the two states remains the same. I have doubled the volume, so V2 is equal to 2 times V1. And what I'm looking to find is the pressure of the ideal gas in state 2. The way that we can work with two states, an ideal gas involving two states, is the following. We can divide both sides and see what we get. So P1 V1 divided by P2 V2 equals nR T1 divided by nR T2. Now, this is the reason why we divide. The number of moles remains the same for the two states. I'm not letting any atoms of the ideal gas escape, or I'm not adding any atoms to the ideal gas. I keep it in a sealed container, if you want. The constant cancels out with the constant. I mentioned that I keep the temperature the same between the two states, so all of these actually cancel out. Now, I have said that I'm doubling the volume in state 2, so really I can write P1 V1 divided by P2. Since V2 is 2 times V1, I can write V1 2 times V1, and this allows me to cancel V1. And since on the right side I was able to cancel out everything, this is just 1. So the pressure in state 2 for the ideal gas is simply the pressure at 1 divided by 2. Now, in my previous example, I found that the pressure at state 1 was 1.9 times 10 to the 7 pascals. So this is divided by 2, and this is the pressure in state 2 of the ideal gas in state 2. So this is the strategy you can use when you have an ideal gas going from one state to another state. If you have some information about the temperature, the pressure, or the volume, write the ideal gas law for your ideal gas in both states, and then divide both sides and use what you know to solve for the unknown. This is the easiest way to deal with it. Now, In my example, I had the number of moles stay constant from one to another. So it was I just canceled out, and you can cancel out the constants. And you can do this if your system, if your ideal gas goes from one state to another state, another state. You can do this process one more time.